The first place to start here is to talk about what are our total requirements for energy in our data centers right now. As of 2023, actually, is where this number came from. I haven't seen any numbers yet for 2024. Our global data centers were consuming around 200 terawatts of electricity every year. That's terawatt hours of electricity, that is. So that would be equivalent to burning about 30,000 tons of coal. To put that another way, that would be 300 train cars just to power the servers for a single year. And the cost of this energy consumption, well, it's driving electricity rates up by about 3 cents per kilowatt hour, and that was at the end of 2023. As we know, those costs have gone up a lot more than that, haven't they? At least mine have. So for everyday users, that might not seem like a big jump, but let's take a gaming rig that uses, let's say it's modest, let's say it's about 550 watt hours. So for an 8-hour session, that's going to cost you about 13 cents at the price increase of 2023. So over a year, that's about $15.60. Now, like I said, mine has jumped a lot more than that. And I'm betting yours probably has as well. So now multiply that by the number of devices that are across the entire globe, and I think you get the idea of that is a major issue, right? That the amount of energy we're using. But does that mean we just turn it off? Well, it's kind of hard to play a game with your computer off, isn't it? Our reliance on finite resources like coal, oil, and natural gas, those demands are going to grow, and the projections are at about a 50% rate. That's horrendous. So the cost of energy is going to continue to climb, and this isn't some distant problem. It's a challenge that is facing us right now. There's an underlying problem here that we need to talk about, and that is the Landauer limit. Why is energy consumption in computing so hard to solve? And why is it so high? Why 550 watts? I mean, that used to be of incandescent bulbs. That would be 5 incandescent bulbs being on in your house for that 8-hour period of time, or 6. So to answer that, we need to go back to physics and the Landauer limit. In 1961, a physicist by the name of Rolf Landauer demonstrated that erasing a single bit of information out of memory has a tremendous amount of energy cost. Why? Because erasing information increases entropy. And entropy, whenever it increases, that generates heat, a lot of it. So the Landauer limit defines the theoretical lower bound for energy dissipation in computation. Once you reach that, you can't go any further. Now Landauer did try to figure out, well, is there alternative ways of managing memory that would cost less than what we're currently doing now? And he found the answer being what he called reversible memory, which meant that you had to store off one of the inputs that went into the gate before being written into memory. That way, instead of having to erase memory, you could just flip it back to what it was. The cost to write memory is, in terms of energy, is very, very small. It's minuscule. The real cost comes if you execute an erasure. That's what takes the energy. So if we could just write over it, that'd be great. That would be a heck of a lot more energy efficient than what we're currently doing. But right now, are we worried about hitting the Landauer's limit? Well, if you look at the graphs, you're pretty far away from it. But the problem is that technology and CPUs and memory is accelerating at a tremendous speed, and it's not going to take them very long to reach it. The current projection for reaching the Landauer's limit is 2030. Another 2030 deadline. I think it's funny that everything seems to be converging on 2030. And that's mostly because of wasting energy due to irreversible erasure of information. There's something called the adiabatic computing model. Now, that model has to do with managing the state transitions in your CPU. Right now, there are 4 states that your CPU typically goes through. There's the fetch state, where it fetches the instruction from memory. It has to decode it, so it has to take that instruction and decode it into the signals it needs to place on the circuit, so that the circuit needs to know how to execute. So there's a decode, and then it executes that instruction, and then it takes whatever data that it got from the execution and stores it back in memory. The problem is each one of those state changes occurs very rapidly. What the adiabatic computing does is it turns up the energy slowly during that transition. Rather than just click it over, it kind of ratchets it up and slowly accelerates fission, and it reduces energy waste, heat, reduces the amount of heat that comes off of that state transition. This sounds like it's just going to kick the can down the road, right? Yep, that's exactly what it's doing. It's kicking the can down the road. The graphs that I have seen show the projections, if we implement both reversible and adiabatic, we might be able to push reaching the Landauer's limit to somewhere around 2045. That's a pretty long way away, right? I mean, that's 20 years from now. And that would give us time to develop these other technologies that have been languishing. And what would some of those technologies be? One of the next generation technologies, these were worked on 20 years, 30 years ago. There was a lot of research going on in biological computers. In fact, some of that stretches all the way back to the 80s. The attempts to use DNA as storage devices. Microsoft actually has continued to do research in DNA-based storage. And as funny as it may seem, the very first video I did for this channel was on storage systems and how they are evolving. DNA was one of the subjects of that video. And just to give you a view of the scale, if we were to use DNA to store the world's information, you could distill it all down to fit inside of a shoebox. And it would operate at near zero energy use. Microsoft was still encountering some of that, but there are newer ways of writing into DNA and newer ways of reading DNA that are much faster than they were, 30 years ago. And probably even 6 years ago. Because they are continuing to work on it. Now, the burner is coming back up on DNA and protein-based computing because they solved the problem of this energy use. There are problems that offer incredible amounts of parallelism that DNA and protein-based machines could solve. It's kind of moving the model closer to the way we work, our way our brains work, and gives your computers some problem-solving power that it wouldn't otherwise get. This would benefit not only conventional computing, but also quantum computing, and it would invent a new kind of computing called neuromorphic computing. So these technologies could redefine what's possible, and it's looking at solving the Landauer's limit and creating a breakthrough that's been needed for some time to move beyond silicon. Silicon is not going to be viable for much longer. There are other limits with silicon that are in the wings, and there is a limit on how far you can make something small. There is a limit to that what we currently understand that you cannot go beyond. So what does this mean for us? Let's put that, I guess we need to really put this in terms of what the future might look like. So, as you know, NVIDIA announced their 5090 GPUs. we were all kind of hoping AMD would announce their new GPUs, but they didn't. They didn't say anything about it during the keynote, but they did provide press information later about those GPUs. And some of the folks like Paul's Hardware and so forth found some of those GPUs that were being displayed with very little information about them. But if you think that your only barrier to purchasing a new graphics card or a new CPU might be the cost, think again. There's another thing that's going to may prevent you from buying that hardware. There are regulations both for data centers and for pre-built PCs. I don't know what laws are like in the European Union or in the Asia Pacific. But if you do, if you know of these kinds of laws, let me know in the comments below what those might be, because I don't know. I know of the ones here. So there are on pre-built on pre-built computers, there are limits on how much energy draw those machines can have. Now currently, it doesn't impact individual devices, but I can foresee they'll correct that problem as soon as they realize their mistake. So you can go out and buy an RTX 5090 and use, whatever that's going to be without a problem. But if that were sold inside of a complete system, that may prohibit it from being sold there. And Dell, by the way, has already written about running into that problem in California, that there were already instances of their Alienware. So let's look at the next thing that might be able to help us, technologies that might actually be able to reduce energy use. One of the ones that was discussed at the NVIDIA keynote for CES 2020 was DLSS 4. Now, I was sitting on the channel with a bunch of people. It was a YouTube channel was rebroadcasting it live, and they were giving commentary. The people in chat were giving commentary. And I noticed that there was a lot of interest during the RTX 5000 series product announcement, but as soon as it turned to DLSS 4, the gamers were like, I am not using that. It'll just be another thing I turn off. And I didn't, I'm not a gamer, so I don't understand all the intricacies behind it. I understand how it works. You use AI to pre-generate frames that of the game that can just be used during gameplay without having to regenerate those frames. And then you just change the parts of the display, change dynamically during the gameplay. But the gamers were like, well, the problem is that DLSS 4, it works, but it blurs the image. So you can't really see with all clarity what's going on. Well, that's important to a lot of visual acuity is very important in certain kinds of gameplay where it's fast paced and you gotta see your target before they get you. So I think that's where I'm going to end things today. And if you've got some comments or some things that you know about, please put them in the comments below. And if you know of energy use limits and legislation that's coming in your area, let me know that too. I'd be interested to hear. And thanks for watching. If you like these kind of videos, subscribe to the channel. I do these periodically, not always, but periodically do these. Most of my videos are confined to Linux, but that's where I try to stay most of the time. But I do branch out occasionally and talk about Windows and talk about Mac OS once in a while and FreeBSD, which I have a long affinity with because I started out in Unix years and years ago. Anyway, that's all I had for today, and I hope to see you on the next video, and bye for now.